Let's discuss the technique of substitution. This is lesson 5.2, and you've been working on anti-differentiation, otherwise known as integration, and there are a few integrals that require a little more work than just the sum rule or the reverse power type rule. For example, if you look at the integral e to the power of 3x dx, you can notice that if I let a variable u represent 3x, then this portion of the integral could be written as e to the u, which would be easier to integrate. But the idea is we would have to have an integral that was with respect to u. So the way we work this is we make a substitution just to try it. Then we take the derivative of u with respect to x, and we get 3, which means the differential du is 3 times dx, which means, if you will, that 1/3 of du is the same as dx, and this gives us a way to completely reduce the above integral and rewrite it in terms of the u variable. Okay, now watch what happens. Three x is replaced with u. Dx is replaced with 1/3 du. The new integral becomes 1/3. We can pull out scalars, e to the u du, and in our previous lesson we discussed that the antiderivative of e to a power with respect to that power is itself, and then antiderivative is generalized with a constant, and then we can go back and rewrite the integral in terms of the variable x by resubstituting the value of u. Okay, so that's just one example of substitution. Let's see if we can do another one. Okay, let's try this guy. The antiderivative of the square root of 3x plus 1. Now, let me just do a little side work over here. Here's what we know. We know that if we were taking the antiderivative of simply the square root of something, then we could reverse the power rule. Add 1 to the exponent, adjust the coefficient, and add the constant. Okay, so we know this sort of thing. So the principle of substitution is to take what you have and make the original integral a little easier to handle. Okay, so let's try it. Since we have the square root of something, let's just try letting the u be what's under the radical. Go through the normal process of taking the derivative of the substitution variable with respect to x, so that you can then rewrite the differentials however you need them to be. And we can note that here dx is exactly the same as 1/3 du. Now, I'm going to do this one a little bit differently. I'm going to do the substitution integral down here. Here's what we have. We've replaced 3x plus 1, and we are replacing dx with 1/3 of du. You can pull out scalars, just like you can with derivatives, and we can reverse the power rule, add 1 to the exponent, multiply by the reciprocal, and add the constant. And then notice that you can do a little cleaning up here, okay? And when we go back to our original integral and substitute the value of u, we see that we really have 2/9, 3x plus 1 to the 3/2 plus c. Okay, but I have to make a comment here. The only way this process really works is when you take the derivative of your substitution variable, that it allows the substitution for the differential to be flawless. Let me give you another example. What if I wrote this guy? Okay, as I said in a previous lesson, we do not have a hard and fast product rule, nor do we have a hard and fast quotient rule for antiderivatives. However, if you notice that you can antidifferentiate e to a simple power, and notice that if I let u equal x squared, then the derivative of u with respect to x is 2x. So it has an x in it. So du is the same as 2x dx. Okay? Now what's important about this, if you notice right here, we have that guy right here. When you substitute, you have to be able to replace everything in the original integral. Okay, so I can notice that I can replace x times dx with 1/2 du. Okay, so keeping that in mind, I'm going to go back to my original integral and realize that multiplication is commutative. I'm going to take my substitution integral now and realize what I'm saying is we have e to the u times 1/2 du. So again, we took all of this and replaced this part, and then all of u replaced that guy. Okay? Now we can do the integral that's easier. And the antiderivative of e to the u with respect to u is simply itself. And then go back to our original and produce the original antiderivative. Okay. We'll do a few more examples in the next session.